All right, good to see you again today, math students, virtually of course. This is the Flipped Classroom Continued. We're going to start today on what's called integration by substitution. This is section 4.5 in your textbook. And as I said before, this is integration by substitution. If you need a page reference, this is page 292 in your textbook. Now, for this particular Flipped Classroom video, I'm just going to highlight some things I want you to look at in your textbook before coming to class on Monday, okay? And I'll explain more what these details are, but I'm going to highlight some things I want you to look at, some things I want you to jot down in your notes, because one of the techniques of the Flipped Classroom, as you know, is to make sure the students did the video assignment and also the reading assignment that I'm going to give you. And we're going to have a quick quiz at the beginning of class just to make sure that you did this. And the quick quiz will essentially be the same material that we covered in the video and in the textbook, okay? So as long as you follow the instructions that I'm giving you now to do, and also I'll email you some written instructions on Blackboard that will give more details. But essentially, there is a formula that deals with composite functions because we are concerned here with the integration of, I'll fill in the blank here. Anytime I do that, as you know, that means it's a very important concept. We're concerned here with the integration of composite or composite functions, okay? So what we're concerned with doing is we have an integral, okay? And it's f of another function. Let's call it g of x. I'm writing it small because I want to emphasize that we're integrating a function of a function. That's what a composite function is. So if you recall your notes from a few weeks ago, a composite function is defined as a function of a function. So you would agree that this is truly a function of another function, g of x, okay? And this is times derivative of g dx. The antiderivative would be f. Again, I'm going to write the g of x small to emphasize that we're doing a function of a function. Plus c. Okay? Now, to kind of make the notation a little bit easier to read, we're going to do some substitutions. We're going to say u equals g of x and du equals g prime of x dx, okay? And what you'll see is if I do that substitution on the next line, the notation will be a lot cleaner to read. So if everywhere I see a g of x, I'm going to replace it with u. Everywhere I see a g prime of x times dx, I'm going to replace it with du. So if you do that, you're going to get the following expression. F of u du equals capital F of u plus c. Okay? So let's go ahead and analyze the pieces of this function. This is called the outside function. This is called the inside function. And this is called the derivative of the inside function. Okay? So, now this is where I'm going to tell you to refer to the book because, like I said, for one of the earlier lectures virtually is the purpose of the flipped classroom is to put the responsibility of learning back on you, the student. So I'm actually going to ask you, even though you may not understand everything you're writing, I'm going to ask you to go back to your textbook and take notes on the following, okay? And we'll discuss more of these in class. So, what you need to do is go to your textbook, look on page 294, make sure that's the right page. I'm sorry, 293. 293. And I need you to add example 1, example 2, and example 3 to your notes. So this is page 293 to 294. So I need you to do that, okay? And again, I know you're not going to understand quite everything you're writing, but again, we are going to have a quiz, and the quiz will be exactly like the examples. So as long as you do your work and read the book, write the examples down, you're guaranteed to get 100 on the quiz, because that didn't happen last time. If you recall, the class average in the last open notes quiz I gave, where the problems were the same, was about a 60. There's no reason why we should have a 60 quiz average. It was open notes and the problems were the same, okay? So please do this work, okay? All right, so the next thing I want you to do is go to page 295 in the book. So I want you to go to page 295 in the book. So this is like an assignment. You can think this is a reading assignment. So go to page 295 in your book and read up on change of variables. There's a formula for that at the top on page 295. Write that down. But what I want you to write down in your notes is, this is page 295. Write down example 4, example 5, example 6, and this is page 294 through 296. Yeah, 295, I'm sorry, through 296. And I want you to write down in your notes the guidelines, because in class on Monday, I want you to have all this in your notes, because we're going to be moving fairly quickly. So if you have all this written down already, it'll help us move a little bit faster, okay? So there's some guidelines that I want you to write down. These are on the bottom of page 296. Write those in your notes. Again, that could be part of your quiz also. And on page 297, I want you to write down the general power rule for integration. So that's on page 297 in your book. I want you to write down the general power rule for integration. It's on page 297 in your book. And I want you to add example 7 to your notes. So example 7, that should be your notes for Monday. That's part of your preparation. Example 7 on the same page. And to kind of wrap things up here, there's a change of variables section in your book. That starts on page 298. So let me write over here to get some more board space. So on page 298, that discusses change of variables. There's a formula. There's a formula for that. And I want you to write that formula down. And there's also examples 8 and 9. Okay? And I know this is a lot, but again, one of the things expectation in the class is you're supposed to spend about, roughly an hour to 2 hours a day outside of class. So this is definitely within those time constraints I established for you. So the final thing I want you to write down from your textbook is the topic that deals with the integration of even and odd functions. So I'll write that here. Hopefully you wrote that down. You can always pause the video if you didn't. So that's not a big deal. You can always pause the video if you didn't write that down, or go back in time on the video. So the last thing I want you to write down is the integration of even and odd Functions. That's on page 300. That's on page 300. I want you to make sure you write down the theorem that's listed in your notes, and I want you to write down, so first of all, the theorem, don't worry about the theorem number, just the contents of the theorem, and the pictures associated with the examples. And the example that's given in the book is example 10. Example 10, that's on page 300, okay? So, again, if you do these things, the quiz on Monday is going to be exactly like it's going to be some random selection of some of these examples. So as long as you have those examples in your notes, you are guaranteed to get 100 on this quiz. Because why? I want to encourage you to read the book, get familiar with reading the book, and I want you to just be prepared for class because it's going to be a lot of material. But if you have the guidelines written down that I erased here, and you have these examples, we'll be able to move the material a little bit faster. But to finalize this particular virtual lecture, I want to do one example. It should only take a few minutes, but it's going to actually exercise the four-step process we've been discussing all semester. Because one thing I want you to understand is that four-step process I gave you is pretty much going to work for most of the problems that we do in calculus, okay? And if you recall that four-step process, you could probably say it to me right now by heart, okay? Well, let's go ahead and review it just to make sure that you know it. So the four-step problem solving process we've been discussing is one, you state the formula, state the relevant formula, you label the relevant data, you substitute the relevant data into the formula that you stated, and number 4, you solve the problem. So let's go ahead and apply this to a topic that you're familiar with because I want to prove to you that this works. So you've used this in previous sections. Now we're going to use it for something that you're not familiar with, but it will help you have a consistent process and framework for solving problems, okay? So let's go ahead and do a problem here. So the general power rule integration I told you to write down looks like this. Integral, well, first of all, let's do the specific one. X to the n dx equals integral, I'm sorry, it should not be an integral there, equals x to the n plus 1 over n plus 1 plus a constant. Okay, so that's what you learned a couple of weeks ago. But now we're going to come up with a general version of this that uses integration by substitution. We're going to replace x with u. So what I do, everywhere there is an x, I replace it with a u. So is that clear? Everywhere there's an x, I replace it with the letter u. Okay? On both sides. U n plus 1 over n plus 1 plus c. Okay? So now we're going to do an example. Example. Integrate x to the third plus 5 to the 3/2 power okay? So here's our example. And what we're going to do is we're going to follow a simple 4-step process that we've been doing all semester for different types of problems. What I want you to do in math is don't focus on memorizing problems, focus on understanding a general process and applying that process to many problems, okay? That's one thing you want to learn how to do in math classes, okay? So, the first thing we're going to do is we're going to state the formula. Well, this is the formula, but it's this formula, okay? This is the one you learned earlier, this one's the one we're doing now. So we're stating the formula, that's the formula. We are going to label the data. Well, in this situation, if we label the data, u equals x cubed plus 5, okay? N equals 3/2. I'm just basically looking at what the exponent is. The exponent is n, right? U is what we're raising to that power. Now, what we haven't found is du. Well, we know that du dx is the same thing as d dx of u, correct? It's just a different way to write du dx. And if that's true, we know that this is the same thing as saying d dx. By substitution, u we label to be x cubed plus 3. I mean x cubed plus 5. So x cubed plus 5. Derivative of x cubed plus 5 is 3x squared. Derivative of 5 is 0, so we leave that off. Okay? So let's see if we label everything in the formula. We find this, yes. We find that, yes. We found this, yes. That's what, oh, we haven't found this yet, so let's continue. So du dx equals 3x squared. Now granted, this is not a fraction, but this is a good way to remember it, okay? If we multiply both sides by dx, figuratively speaking, you know, I'm not really doing that, but it's a good memory device. The dx's cancel out, correct? Those cancel out. So we're left with du equals 3x squared dx. So now we label everything. So we have a u, there's the u. We have the n, there's the n. We have the u over here, same thing. Well, n plus 1, we didn't do that, so let's do that. N plus 1 equals 3/2 plus 1, which equals 3/2 plus 2 over 2. I just changed the 1 to 2 over 2 so I can add the fractions, okay? So that's going to be 5 over 2. So we had n plus 1, so let's check again. Let's check, make sure we have everything. Because what am I doing? I'm doing this general four-step process we've been doing most of the semester, and I'm telling you that it will work for the rest of the semester, okay? So we have the u, yes. We have the du, yes. We have the u, yes. We have n plus 1, yes. We just found that. So in the c, it's just a constant, so we don't have to worry about that. So guess what? We have labeled all the relevant data. We've done the first two steps. So in the exam, if you've done these two steps, you've gotten half the problem right, okay? Now let's substitute into the formula. So right now we're doing step 3 in our 4-step process. So this is the formula. So let's go ahead and substitute. Integral u x cubed plus 5 du, let's see, du is 3x squared dx. Look what we have here. There's x squared. So let me tell you what we have to do. We don't have a du in our problem, so what are we going to do? We have to create a du. Because here it says du is 3x squared, correct? Do you see that? It says it's a 3 in front of here. So what am I going to do? I'm going to add a 3 here. You may say, you can't do that, you're changing the problem. Yes, I can. If I put a 1/3 here, I have not changed the problem because 1/3 times 3 is still 1. 1 times anything is itself. So I have not changed the problem. All I've done was make the problem fit the definition of my formula, okay? So does that make sense to everybody? I put a 3 here so I could have a du. And then I add the 1/3 so I don't change the problem because 1/3 times 3 is still 1, okay? So I'm going to add a 3 here. And that's going to be 1/3. Now I can proceed with the rest of the formula because I cannot proceed unless everything on the right-hand side, the left-hand side is satisfied. I cannot proceed. Now I can proceed. So that's going to be equal to, let's bring over the 1/3 here. So 1/3. U is x cubed plus 5 n plus 1, let me just write that a little bit better this time. So x cubed plus 5. And just to make things look visually more appealing, I'm going to use a square bracket here. Okay? X cubed plus 5. And n plus 1 is 5 over 2. N plus 1 there is 5 over 2. We found n plus 1 over here. There's the work for it. And all that plus a constant. So we finalize everything. We have 1/3 times 2 over 5 x to the third plus 5 to the 5 halves. Well, since 1/3 times a constant, I can still say it's a constant, right? So that's going to be 2 times 1 is 2, so that's 2 over 15, x cubed plus 5 to the 5 halves plus c. All right, so that's the final answer. At home, what I want you to do is, I want you to check this answer by taking the derivative. I want you to do that at home, okay? But please make sure this example is in your notes, because this could be something that I put on the quiz on Monday that's open notes. So you want to make sure that everything I told you to do this particular virtual lecture you've done so that you get 100% on the quiz on Monday, okay? Because it will be open notes and the problems will be exactly the same as what I went over today with you for the virtual class.